Hello everyone, welcome back to the Programming One course presented by me, Dr. Aisha Qureshi from the Faculty of New Technologies of Information and Communication within the Department of Computer Science and Information Technology at Qasdi Mirbah University of Wurgla. Before we begin, I would like to share that I have chosen to present this video using interactive version of the course. This allows me to explain the content clearly while showing examples in real time. I believe interactive courses greatly enhance student understanding, making abstract concepts more visual, practical, and easier to follow. Let's start our course. The first question is, who is this course designed for? This course is specially designed for first year students in medicine and big data program, where the lecture provides a solid foundation in programming concepts using algorithmic and Python language. The course is organized into 6 practical and progressive chapters. The first chapter is an overview of programming. The second chapter is about sequential algorithm. The third chapter discussion on control structures including conditional. Then in the fourth chapter, overview of looping mechanism like for and while loops. The fifth chapter is about arrays and string. And finally, in this sixth chapter is an explanation of custom data types and their significance. For more information, I have included the mind map of the course to my students. So let's take a look on it. So the mind map contains all informations about the course. So let's back to the course. So to follow the course effectively, students should have basic computer literacy, understand simple mathematical expression and logic, be comfortable reading and writing in English. It should be noting that no prior programming experience is required for this course. So, by the end of this course, students will be able to define the fundamental programming concepts, explain the role of algorithms in specifically in medical and big data contexts, write basic Python programs, analyze algorithmic solutions, design and implement complete programs that simulate medical data processing tasks, and evaluate the effectiveness and the clarity of written code and algorithms in solving domain specific problem. So to help my students to assess their readiness, I have included a pre-course self-evaluation quiz. So the quiz include some basic question. So our objective for today, we are focusing on chapter 2, which is all about the sequential algorithm. So let's move to chapter 2. This is which is sequential algorithms is one of the most fundamental concepts in programming and especially important when we begin applying logical to real world problem in medicine and data analysis. But before we get into the details, let's briefly recall what an algorithm is. An algorithm is a finite sequence of well-defined instruction written in natural or programming language that we follow step by step to solve a specific problem. In a simple term, it's like a recipe. Each instruction has a clear role, and when you follow them in order, you get the desired results. So what we will see in this chapter? In this chapter, we will cover how to write your first algorithm, the importance of defining inputs, outputs, and logic, how to translate an idea into a pseudocode, and finally, how to implement that algorithm in Python. So, firstly, writing an algorithm involves defining a clear step-by-step process that transforms inputs into the desired output. The key steps to write your first algorithm are as follow. So, we have 6 steps to follow. The first step is the most important, is understand the problem. The first and the most important step in writing any algorithm is fully understanding the problem to be solved. This includes what? Identifying what is the goal of the algorithm. So what is the problem exactly? What is inputs are needed to reach the goal. So any problem have an input data, and what should be the final output. So if you define the problem, so you should know what is the desired output. You know the desired output. So an example, let's give you an example in medical context. So I will give you an example about an algorithm might calculate a patient body mass index, which is a BMI, which help assess health based on weight and the height. So this is the problem, calculating BMI. So the second step is defining the inputs and the outputs. The inputs are the data necessary for the task. So we have the problem, of course we have a data as inputs, while the outputs are the result produced by the algorithm. So the outputs are the desired or the expected results. Defining this clearly is critical. Let's talk about the example we have choose is calculating BMI. So as input, what we have, we should know the height and the weight of the patient, the weight in kilograms and the height in meters. So what is the expected output is the result of the value of the BMI. The third step is outline the steps. So to go through from the inputs to the outputs, so we need to follow some steps. So we should outline those steps. After defining the inputs and the outputs, the next step is to outline the sequence of operations required to transform the inputs into the outputs. So by taking the example of calculating the BMI, we have as inputs the values of the weight and the height. So the expected results is the BMI value. So we need to read. Firstly, we need to read the patient weight and height, use a formula. We have a fixed formula, mathematical formula to calculate the BMI. So even we get the value from the formula, we return or display the BMI value. So what is the next step? We have our inputs, outputs, and the steps. So we should, once the steps are outlined, writing them in pseudocode, which is what is a pseudocode? Is a way of describing the algorithm in a plain language or a human language, focusing on the logic. And here is an example of algorithm written in pseudocode. So we should to define the keyword algorithm, and we will name the algorithm should have a name. So we define the input firstly, the outputs, which is the declaration part. Then if any algorithm has a beginning and ending, so begin and the instructions, and finally the end. So the fifth step is test the algorithm with example inputs. Before converting the pseudocode into a programming language, it's important to test the algorithm within real data to ensure its work correctly. So the final step is to translate the pseudocode into a programming language such as Python. So let's move to managing data, variables, constants, and data types. So data is a fundamental aspect of algorithm. Efficient data handling enable to processing of the input and generating meaningful outputs. So a variable, let's define what is a variable. A variable is a container that stores data that can be changed during the execution of of an algorithm. It acts as a placeholder for values. So what are data type? Defining the kind of data. In algorithm, each variable must have a specific data type that determine the kind of data it holds. As we said, that a variable is a container. So what does this container holds? The kind of the data it holds and how it can be used. We have some common data type include integer, float, string, and boolean. It should be noted that in Python, variables automatically take the data type based on the value assigned. So here I explain the example of BME calculator. So one which is one of the most commonly used medical calculation is the body mass index BMI, which helps determine if a person weight is appropriate for their height. So let's give you just an overview about an introduction to Python. So Python is a high-level interpreted programming language known for its simplicity and readability. So why Python for this course? So Python is easy syntax, interpreted language, cross-platform, and rich libraries and frameworks. So a Python program is structured within specific elements that contributes to its functionality. These elements includes comments, import statements, functions, variables, and the main execution block. So thank you for your attention and for following along with this session. Today we explored chapter 2, sequential algorithm, one of the most essential topic in programming. We discussed how to break down a problem, define the input and the output, write logical steps in pseudocode, and implement real-world example using Python like the BMI calculator. Understanding these fundamentals is key to write effective programs, especially in a field like medicine and big data, where precision and logic are everything. In the next chapter, we will introduce control structures, learn how to make your program smarter with conditions and decision making. Until then, I encourage you to review the course interactively, complete the exercises, and to try writing a few algorithms of your own. Thanks again, and see you in chapter 3.